All right, let's get right into it. Today, we're not just going to answer an exam question. Oh, no. We are going to crack the code. We're going to pull back the curtain and see exactly what you need to write to get every single mark. We're taking a real GCSE chemistry question 3 to be exact, and we're going to deconstruct it using the official mark scheme. Think of this as your all-access pass, an inside look at what the examiners are actually looking for. So, things kick off with the Haber process. You know it, you love it. This diagram shows us nitrogen and some other gas, which they've called gas X, going into the reactor. Let's tackle the first couple of questions on this.
Okay, first up, question 3.1, 1 mark. They even give you a massive clue. It's made from methane. So what's that other essential gas you need for the Haber process? Have a think.
And boom, there it is. The mark scheme is super clear. Just say hydrogen. Or if you prefer, the chemical symbol H2 works too. That's it. 1 word, 1 mark. That's what I call easy points. Right, moving on to 3.2. Now they want the conditions inside that reactor. It's a 2-marker, so you know they're going to be looking for 2 key bits of info, the temperature and the pressure.
Now, this is really important, so listen up. The mark scheme doesn't ask for one single magic number. It gives you a range. Any temperature between 400 and 500 degrees Celsius is fine. Same for pressure. Anything from 150 to 250 atmospheres gets you the mark. That's such a crucial tip. You don't have to memorize one exact value, just the zone it's in.
Okay, so the gas mixture leaves the reactor and heads into the condenser. We can see ammonia comes out as a liquid, but the other gases just get recycled. This next question is all about the why. So what is going on here? Why does one gas decide to turn into a liquid when the others don't, even though they're all cooling down together? It's time to dig into your knowledge about changes of state. And the answer boils down to, well, boiling points. That's literally it. That's the key phrase the examiner is searching for. Ammonia has a higher boiling point than nitrogen and hydrogen. So as everything cools, ammonia hits its condensation point first and turns to liquid. The others stay as gases because they're not cold enough yet. Simple, precise, and a full mark in the bag.
All right, deep breaths. This is the big one, the main event. It's the 6-mark question. Now, for these big questions, you can't just throw down random facts. You've got to tell a story, a logical, connected explanation. Let's break it down piece by piece. First, they give us this table, and whoa, just look at the difference between Venus and Earth. Venus is basically all carbon dioxide, and Earth, well, it's not. The whole idea here is that Earth's early atmosphere probably looked a lot like Venus does today.
And here's the question. See that word? Explain. It's everything. You can't just list the changes. You have to explain the processes that made the carbon dioxide drop and the oxygen appear. For 6 marks, you've got to build a case. So, according to the mark scheme, here's part 1 of the story. Picture it. Early Earth. Volcanoes erupting, releasing tons of water vapor. That vapor cools, condenses, and boom, we get oceans. This was a total game changer because that pesky carbon dioxide just loves to dissolve in water. It led to carbonate rocks forming, locking away massive amounts of carbon. But wait, the story's not over. Now, life enters the scene. Algae and plants start to evolve. And what do? They start photosynthesizing. They breathe in that carbon dioxide and, this is the critical part, they release oxygen. This is what gave us the air we breathe today. Plus, even more carbon got locked away in these living things, eventually becoming our fossil fuels. And here it is. This is the real secret code to the big questions. You're not just graded on a checklist of points. You're graded on your level of response. To get those top marks, that level 3, you can't just list facts. You have to connect them. Create a chain of events, just like we did. Volcanoes led to oceans. Oceans let CO2 dissolve. Plants evolved, and that gave us oxygen. A clear story gets the top marks. All right, we're on the home stretch. One last little question. This one's a bit different. It's not about explaining a process, but about understanding science itself. After that massive 6-mark explanation, they ask this. For 1 mark, why can't we be 100% certain about any of this? It's actually a pretty deep question about how science works. And look, the mark scheme gives you a few perfectly good answers. You could say it was just a crazy long time ago, we're talking 4.6 billion years. Or you can say there's very little direct evidence, or even just no proof. Any of these simple statements will get you the point. Okay, let's pull all this together. That was our little masterclass on question 3. So what did we actually learn about how to crack this exam code?
Here's your checklist. You've got to use those exact keywords like hydrogen or boiling point. Remember that sometimes there's a range of correct answers, not just one number. For the big 6 markers, tell a logical story. And finally, be smart enough to know what we don't know. Understand the limits of the evidence.
This quote absolutely nails it, doesn't it? That's what this all comes down to. A top grade answer isn't just about being right. It's about structuring your answer to prove without a doubt that you really get it. So there you have it. You've seen behind the curtain. You know how the mark scheme thinks. You have the strategy. The only question left is, what are you going to do with it? Go out there and conquer that next question.